So calculation-wise, I think that's all well and good. And this is where I kind of got a bit stuck yesterday with talking about like the angle between two vectors. But this is the identity that we need in order to like understand where this angle between vectors formula comes from, right? The way I derived it, if you remember, I used the cosine rule, and we were saying, okay, if I have this triangle here, so VU, we were essentially applying the cosine rule here to think about, hey, what's the angle that's going to be between these two vectors? And the tricky thing when we're working with like geometry and vectors is that when you're talking about the lengths of these vectors, you actually have to deal with the magnitude because the vector itself doesn't give you a length of any sorts. The way that we've calculated things in the past, that we've required the lengths of each of the sides, right? So we need to be able to actually find its magnitude in that way. So they use P's and Q's, but same idea. Put P and Q just to make it clear. Okay, so on page 23, a few things to note, right? We have this kind of like alternate form for the dot product now. We know that there's a relationship between the angle between two vectors and the dot product that we take. So there's like another definition. This is a way in which we multiply the x coordinates, x values and the y values and put them together. But there's also this one that incorporates the magnitudes and cosine, right? And a very important relationship which exists between them is thinking about, hey, okay, what happens if my vectors are parallel or perpendicular? What's going to be happening? So just have a look up here. So if my vectors are, let's do perpendicular first, because that's easier to determine. If my vectors are perpendicular, this applet calculates the dot product. Have a look at what happens. What happens to the dot product when they're perpendicular? 0. Why is it 0? There you go. So if P and Q are perpendicular, because of the nature of this form now, this is a bit more informative, it tells us a bit more about what's going on, right? We can see that cos 90 becomes 0, right? Because theta is the angle between the two vectors, so cos 90 becomes 0, and so this whole thing is going to become 0. So if P and Q are perpendicular, then the dot product will just become 0. That's the first thing to note. Next thing to note is what happens if they are parallel. And I think you need to be thinking about, hey, what would it look like if two vectors are parallel? I mean, yeah, it would be like this. In this diagram here, I guess I can't kind of split them up. What I can do is, if the vectors are literally on top of each other, right, then they would be parallel, right? They'd be going in the same direction. How should we do this? Well, what is the magnitude here? I'll write this vector out. These vectors would be like, they're not necessarily the same, but I should probably make them different actually, just to show you clearly what's going on. Yeah. Okay, so if this vector here, u is like, which one's u? That's like 0, 4. And v is equal to 0, 7. All right. Hang on, this looks, so we've got the dot product here is 28. What would be the magnitude of this guy? This would be, 4. Magnitude of u equals 4. Magnitude of u equals to, magnitude of v here equals to 7. 7 and 4. Right, so what we can see is actually what we end up with is that it turns out just to be the magnitudes of these two vectors multiplied together. And again, going back to what Joel said, again, thinking about why that is, well, what's cos 0 going to be? Cos 0 is just 1, right? So the next thing that we can take away is that if P and Q are parallel, then the dot product is just going to be equal to the two magnitudes multiplied together. But is this the only way that two vectors can be parallel? Because we're talking about stuff like this, right? And this is the thing that differentiates vectors from traditional kind of geometry, right? Because usually this is the only way that things can be parallel. If you're just talking about two lines, they're the same distance away from each other. But what makes up a vector? Remind me again. It's not just magnitude. There's also direction. So what if I did this? Are these still parallel? I mean, they're the same distance away from each other, right? And but they're not going in the same direction, right? So in this situation, they are still considered parallel. And in terms of a diagram, what would that look like? Well, it would look something like this. Does that change anything at all? Negative. Right, it becomes negative. And again, because cos 180, that's going to give me a negative 1, right? So again, if P and Q are parallel, we kind of have to make a distinction. That's if it's in the same direction. But then if they're in different directions, so you can say opposite directions, then we're just going to get the two magnitudes multiplied together, but the negative of that. Okay, brilliant. Now I think you've got some questions.